Hello, everyone, and welcome to TechZone, powered by Excedia, a professional IT services company providing technology consulting and software development for businesses around the world. TechZone aims to shed light on how technology products are developed through the experience of software engineers, product people, UI/UX designers, and other experts. Each episode covers a specific software development topic ranging from engineering, product, process, quality assurance, or a management viewpoint. Welcome to the TechZone.
Hello and welcome to the new episode of TechZone. My name is Alex Tudorov. I'm Senior Engineering Manager here in Excedia, and with me I have my friend Martin, who is Big Data and Advanced Analytics Team Lead in Eviden. Hi,
Thank you for
Martin.
having me. It's a
Again.
pleasure to be here again, and I look forward to another interesting podcast.
Yes, most definitely. The things that we have created so far are really great. If you want, you can go back and watch them and listen them as well. Today we have exceptionally interesting topics to cover as well. Let's give a little sneak peek, and after that, of course, we'll dive into the details. But today we're going to talk about outages and service availability when it comes to LLMs. Also, we're going to talk about token limits and rate limits, and finally, but not in a final position, cost management and some strategies in order to optimize costs.
And I bet that there are certain financial experts that are going to find this last topic very interesting.
Yes, and not only. Actually, costs are something that everybody who is doing anything with LLMs need to be mindful of. So stay tuned and listen.
Well, basically, when you talk about someone who is working with LLMs, with generative AI, I believe that in the past few months, I'm not going to say years, but in the past few months, that is basically everyone. And considering the fact that everyone is trying to get a piece of the pie related to AI, no pun intended, maybe it's time to shine a few, get some additional details and shine some light on the topic of outages and start with this because everybody's happy about getting a new shiny toy, a new AI assistant, a new project that is powered by AI, a new tool that is powered by AI, but not maybe everyone is thinking about what could go wrong.
And so far in the times, let's say the couple of months especially, we have seen even big players on the market that it's possible for them to have outages, to have, let's say, not service that's not being provided, something that's not working. And a lot of people, a lot of companies, a lot of products are depending on them. Yes, I'm talking for OpenAI. So this is something that's really important and something that's really happening. So
Considering that OpenAI is, it's a private company, and we can only speculate what might be causing the outages, what could be the root cause behind it. I'm not going to say that OpenAI are covering up anything, not at all. But most important of all is that there are numerous reasons why a proprietary model may not be available at a certain time and why that would be critical for a person or company's business. Maybe we could start with some of the details that we discussed prior to starting this. OpenAI in the past few months have been very open about, again, no pun intended, about their outages and the different types of unavailability that people who are using their services might be having. It's not just OpenAI. Google Gemini has also experienced outages. Other companies, for example, Anthropic and their models, Opus and Sonnet, have also been intermittently unavailable. But probably the spotlight is always on OpenAI as the forefront of proprietary Gen AI models.
Yes, most definitely. I think it's becoming something like a synonym to when you're talking about proprietary model, you're just thinking about OpenAI. This is going to be because probably they have the biggest market share and probably they're the most famous and the most recognizable brand at all. Of course, we're talking about everybody, not just OpenAI. This is something that happens just because. Well, there are a lot of reasons because this is happening, but we as owners, as developers, as people who develop something, let's call it a software application, whatever, on top of LLMs, need to have in mind when we're talking and when we're creating things about with LLMs. So what can we do in order to reduce the risks of outages and how to increase our availability? Is there anything that we can do in order to achieve this?
Consider the following. Imagine that you have a piece of software that is deemed critical to a certain service. It may not be critical as in healthcare, but it might be critical as in providing full coverage of all the support stuff that may be happening related to a website, an online store, a gaming system, whatever it is. Any outage of a single model, if you are putting all of your eggs in one basket, any outage of a single model that you're using is going to be received with very negative feedback from your customers,
Especially if they're paying for it.
especially if they're paying for it.
It's becoming the single point of failure. And so the first thing,
Well, the first thing that you can come up with is even your odds. If you're using OpenAI, maybe add a backup model. And if you are indeed relying on the services of this piece of software to drive your, well, to bring money in the bank, you should definitely consider options, for example, like having your own model hosted on your own infrastructure and being.
or cloud infrastructure, yeah, it doesn't mean to.
Yeah, or cloud infrastructure, of course, and to have this totally under your control, ensuring that your software is either set up to respond to a failure immediately or to have a mechanism that can notify your users or clients that there is going to be a certain period of unavailability that they should be, well, they should either brace for or be prepared that the service is not going to be available for a brief moment. But maybe there are some additional ways that we can manage this in order to ensure that this switchover of different models is going to be seamless for the person who is using the software.
I have seen some really interesting implementations. There is a model that can be used as a router between different requests, and the model in the center of this just understand what is the type of the request, and from there it reroutes to the most proficient, let's say, big model which is going to handle the whole request. And by doing this rerouting, you can make sure that first your requests are optimized, and second, you always have some kind of a backup if one of the models is not responding or not available or something else. It can always go back to a fallback plan and fallback model that is going to handle the request itself.
This is an excellent option, and I believe that this is an already available framework which is called LLM Router. Considering that the implementations are going to get more and more complex as we move forward into adopting generative AI for different purposes, having backup models, whether these are proprietary or these are open source models hosted in your own infrastructure, is going to be a key topic when it comes to convincing someone to provide funding or be actually part of a project that is related to generative AI. There is one more thing that probably can be considered when we are implementing such solutions, and that is having automated switchovers. You mentioned the fallback options, and there are items that can be, there are pieces of software that can actually provide such a sliding window option that can allow for the timely requests and checkpoints whether a model is available or not?
Actually, you mentioned sliding window. This is one of the strategies. There is also the fixed window. Pretty much the difference is that based on previous traffic, it harnesses more resources in order to handle the bigger traffic, and the fixed window is just as it sounds. It knows that from 9 to 10 there's going to be a big traffic, so it fixes and harnesses the resources. And the sliding window is pretty much trying to predict what will happen based on previous, of course, encounters and some insights. And this time frame can work from 9 to 5, from, well, not 9 to 5, 9 to 10, 12 to 1, and so on and so on. So this is one of the strategies, yes.
Considering the other topic that is, well, because right now we're discussing preventing outages, maybe it would be worth noting that sometimes the outage is not actually an outage, it is a degradation. And those degradations are also going to be detrimental to any type of business for sure, whether it is delaying the inference process. For example, we've all seen the case where ChatGPT is taking 15 minutes to respond, and at the end it's giving this red exclamation mark saying model is currently not available. Or there are cases where the service is intermittently available. For example, you have request A passing, request B not passing. And this is also going to be definitely a blow to any business. And what can we do in case we are faced with such partial availability? I mean, this is not a problem of the whole thing going down and being met with their 500 or 400, depending on what you're actually getting at. But you have these intermittent cases.
Well, it's a good question. One of the things that come in top of my mind is something that is called exponential backoff. Well, actually, it's exponential time off. Yeah, it's exponential time off, and pretty much this works for every time you are consuming an API that behind it's an LLM or something. You're making a request, and if this request fails, there is a whole strategy how to handle this failing request. Then you make another request, let's say 1 second afterwards. And if it fails again, then you make another request in 3 seconds, then in 6 seconds, in 12 seconds. And at some point it's going to hit and it's going to work and it's going to provide the corresponding and the right answer. But this pretty much allows you to make sure that your requests to the API are not failing without being handled properly. And also that at some point, whenever the API is available, maybe there are concurrent issues or something that is currently taking the attention of the LLM, but at some point it is going to answer you and it's going to provide you with the response that you want to have. So this is interesting strategy. I think there are frameworks on this. Also, you can, if you want, you can write it. It's pretty much easy coding, or there are frameworks ready to be used just for that.
This is definitely going to improve someone's life in case they're faced with such, such cases. But something comes to mind right now, actually. It is handling cases where you are faced with your own hosted model that is, experiencing some issues. Considering the fact that when you're hosting your own model, you're responsible for your own well-being. There are safeguards.
We can break our things better than anybody can.
Exactly, definitely. And we will likely need at least 5 other people's help in order to find our own problem.
True that.
But at least at that point, when you are hosting your own model, you can take some additional safeguards to ensure that the availability is in no moment impeded by the hardware that you're using. Now, these are basically stuff that you take as a precaution on any VM that you're hosting. You take some load balancing steps. You make sure that you have a backup machine that is ready to switch over and take as a failover machine. You make sure that everything is triple secured. But still, this is something that will drive your costs.
Definitely. And later on, we are going to talk about costs. Of course, we have prepared several strategies that can help you reduce those, but we're going to talk about those in a few minutes. Um, what else can we do in order to prevent? Well, we want to prevent at some point overload of our APIs, of our LLMs. What can we do? First thing, what we can do is implement rate limiting. This is something that we can do. Also, actually, do you want to tell what is rate limiting?
Rate limits with any LLM is basically what rate limits would be with any other
API.
any API. Right now, if we are going to go with OpenAI as an example, OpenAI is having certain tiers at which you have different rate limits which are available for that specific tier. And those rate limits are in several categories. You have limit in terms of numbers of tokens that you have per minute. You have number of requests per minute. And you have, I believe it was a total number of requests.
Actually, I don't think you have the number of requests as a because you have a limitation over the tokens, you have limitations over what was it? The other thing that was limited. I can't remember at the moment, but I think you can have as many requests as you want, but in the scope of the number of tokens that's available to your tier and the number of output completions or something. It was something like that. But it's not. It wasn't requests. It was funny.
The point is that those limits exist because OpenAI don't want to, be victims of DDoS attacks. They want to also make sure that whomever is, paying the most is getting the most service, which also makes sense. I mean, it's a for-profit company at the end of the day, being bought by Microsoft and so on. And anyone who is using, however, their services or Google Gemini's, because they're also subject of the same laws in terms of rate limiting or in token limits, is going to have to make sure that they consider in advance what task they're willing to achieve, what task they're aiming to achieve, what are the costs that they're willing to drive with, and consider that any item that they're going to move forward as a client deliverable in terms of generative AI subject is going to be part of those limitations. But there are ways through which a person who is or team through which person or team can actually safely get around those limits and ensure that the product that they're serving is working at all times, despite being forced at a certain moment to be limited by those options.
Probably I need to mention something interesting here for the people that are using OpenAI APIs. You cannot buy yourself higher tier unless you have the usage for it, which sometimes it's a little bit frustrating because you're predicting that your application is going to have bigger traffic from the get-go, and unfortunately they don't give you option to buy let's say the hosting of the handling this traffic from the beginning. You need to use as much as possible, and then at some point they upgrade you to the to the higher tier. And sometimes this also brings not availability of your application or your service just because it can't handle the traffic. But OpenAI haven't upgraded you to the higher tier, and no matter how much you write them, they are going to do it in their own timing. So yeah, it's fun. But what you have mentioned is interesting. Let's talk about how we can optimize, optimize the work of our application and of course the LLM in order to be able to work in those limitations. Are you talking about token limits or input or?
Because I'm a person who likes the principle of KISS, and I don't mean the rock band, but keep it simple, stupid. I am a big fan of coming up with simple solutions to problems whenever possible. And when it comes to token limitations, the first thing that comes to my mind is how can I make sure that the model is using as few tokens as possible when it comes to system prompts? Because as we all know, the system prompt is going to stay. Despite the future being agentic, most likely, the system prompt in the LLM is going to stay. So, very simplistic way through which you can actually reduce the number of tokens that the system prompt takes up is to do a rudimentary compression of the prompt. And by that I mean you take your system prompt, you pass it through an LLM, and you ask it how this can be reduced in size in terms of tokens so that it is still reconstructible and understandable by you. And for example, the highest rate of compression that I have achieved in this manner is something like 73% reduction of the prompt, which is, in my opinion, a pretty good rate.
Yeah, most definitely. Actually, now that you have mentioned this, I remember that I've seen something that was created from Microsoft. And funny thing to say that Microsoft are developing interesting and applicable stuff for the LLM infrastructure and LLM development as a whole, but they have created a framework, or rather say a library, that pretty much converts not only the system prompt but also the input prompt to a token, to tokens, and it optimizes the input prompt so much that the best results that I have reported is up to 20 times reduction of the token usage.
Most impressive.
Most impressive, yeah. And I haven't tested this myself so far, but I've seen some studies about it. And if this is the real deal, then this is going to be implemented, and this is going to change pretty much the way we not interfere, but interact with LLMs and how we build our prompts.
I hope that this finds more publicity in the future and it keeps getting developed by Microsoft. Because, as you know, they are prone to sometimes pull the plug on some stuff. For example, the GPT creator in Copilot, after 5 months, it's gone. So hopefully this will be available in the long run. Now, we are considering and we're discussing the options to reduce the number of tokens, to do some optimizations, but optimizations and such improvements are great. But at the end of the day, we need to know what we're actually aiming to achieve with our solution powered by generative AI. And as I always use this example, we should pick the right shovel in order to dig the proper size of hole.
There are a lot of stuff that can be done in this direction for us to be sure that we're doing this. There are simple steps that can be done. The first thing first, of course, make sure that you're using the first and the most proper model that you can find for the specific job. But there are some strategies for token optimizations that, even though a little bit rough, or how should I say, possible problematic, are still used, and to some extent they're pretty much bringing value. You can use streaming to trim the first part and the last part of the prompt, and this will reduce the number of tokens that is being used. Of course, there's the problem that it can bring to loss of information, which is not great, but at some point this is totally valuable. Next thing you can do is summarize. This is something that is being used a lot, just to convey the semantic meaning of, for example, a huge text or something. So you are saving on tokens. Next thing you can do, and I know you have some interesting story about it. What can you do when you're handling a huge, let's say, document of text, like a huge PDF or a huge something, and you need to summarize it? Because in this case, there aren't any good options.
Well, this is actually a very good topic, and I will be happy to share with you this. A recent task that I've been handling is a process during which a PDF file is supposed to be summarized. This PDF file contains scanned pages, and those pages are actually written text. However, due to the fact that those are images in the PDF file, we cannot use our traditional approaches. What that would be, take the text from the PDF and send it over to the model so that it is summarized. Probably a step back. How actually the process of sending over a PDF or an image, for that matter, to the model works? Well, it is encoded in base 64 and then sent over. But what do you do when you have a PDF file which is 50 megabytes in size? How do you manage this? Well, there are several approaches. First, you can take the PDF file and each and every one of the individual pages can be taken off as a snapshot, as a PNG, then reduce the size of those PNGs or GPGs, as image files, reduce the files, and pass these over in bulk or as a batch, which is another process which maybe we can...
We're going to talk about it when you're talking about cost optimizations, yes.
So we can send these over to the LLM. But there are other options which I would say are probably more smart. And that would be take the PDF file, use a Python library to reduce its size, turn it black and white, and then you can safely assume that from this 50 megabyte file, you will likely end up with something that is at least 6 or 7 times smaller. Right now, I believe that both Gemini and GPT-4 have a limit of 10 megabytes per file. And having reduced successfully your PDF to something like 5 or 6 megabytes, you're safe to approach. Also, at the end of the day, consider this, whether it is a PDF, a PNG, or any other format for that matter that you are going to have your product work with, you are likely going to end up with encoding this in base 64 and sending this over to the model. So the fewer tokens that you send over, the better your chances are of making sure that you're not a victim of token limits or rate limits.
This is a great advice. And while you were describing the process, I was thinking, how can we handle huge information blocks like a textbook or a book or a lot of books? How can we handle being asked questions about the information in those books and how we are going to optimize this process so it doesn't fall into the token limits and how it can be optimized? And one of the approaches that I think it's really working great, and I have tested this in one of my application, is to extend this into a rack, and the rack pretty much do the semantic explanation, and when you ask it, it just passes the informations from this, let's say, a book, to the LLM, so it can have the context, it can know what's searching for, what's talking about, what is being looked for, and then it can generate a more accurate answer based on this. And this really works great when we're talking about finding answers from huge documents or books or...
Indeed, RAG is the best option for the case where you need to actually find a specific answer. This is definitely going to be, the approach. Something else just comes to mind actually while we're discussing this. Uh, I believe you're familiar with OpenAI's Whisper model.
Yeah.
Yeah. So, Whisper has a very interesting limit. It's 25 megabytes per audio file. But considering the fact that most of the time people would like to actually transcribe something that will likely be bigger than 25 megabytes, it will involve a process of taking the audio, for example, out of a video, then cutting this into individual pieces, then part of that reducing the size, reducing the bit rate, making sure that it can fit into the whole setup. And I take great pride in saying this, but one of my colleagues has actually set up a pull request to LangChain and proposed this as a whole new tool to overcome the limitations that Whisper has. Right now, we are, I believe, at the initial approval because you have several steps. I hope that this gets approved and included into the LangChain toolkit.
Well, that's great, but how how he's going to do the optimization?
He's adding all the steps that I just described in one single tool. And for example, if you have a file that is 2 gigabytes, then he is just asking for the file location and all the individual steps and pieces, reducing file size, cutting, sending over to Whisper, and so on, are achieved automatically through the tool.
Okay, but is it going to split? It can't split the content of this in how should I say, into
Meaningful sections.
meaningful sections. Yeah.
Yeah, that's always that's always definitely something that has to become to be considered. Overlapping is something that is available as an option, and given the fact that we are using LLMs, which are generally, and I'm using air quotes here, smart, any overlaps can be rectified during the actual process of transcribing the file itself.
Okay. Yeah, it's an option because a few months ago I had to implement something like this, and pretty much it wasn't a big pile of text, but still it was a notebook or something. And the way that it worked for me was to manually segregate all the sections into meaningful ways so they can fit into the limitations of the LLMs, and from there be used as references. So yeah, if somebody can find way to split bigger parts of text or notebooks or books or whatever into meaningful sections, I think this is going to be really great. But still, the optimization of your friend is still something that is going to help a lot of people, most definitely.
Hopefully this gets approved and made part of LangChain soon, and I'm certain that people are going to find this useful. But right now, as we're talking about token limits, I believe we actually are very highly overemphasizing token limits. And maybe we can talk a little bit more about the rate limits, meaning the number of requests that are being sent per minute to...
And allowed.
Sorry?
Sent and allowed to be processed.
Sent and allowed to be processed by an LLM. And let's give an example. Imagine the case where you have a website with a massive community that requires an assistant with the ever popular Gen AI solution, a chatbot assistant that is, available on the website. A massive community, let's say some computer game that people are playing, several thousand players, ever presence of public people commenting, asking questions, and so on. This will likely overwhelm any of the current rate limits that are available of most of the lower tiers that OpenAI gets. Well, what can we do about this?
Actually, in people's practice, there are several good approaches to this. From handling it asynchronously, not synchronously. This is the one thing, and this is a great thing if you can if you can allow yourself to make a little delay between the request and the time that you are getting the response. If this is the case, and your case fits this, it's great because it's probably the easiest. From there on, what you can do, you can implement something like a bucket of available requests that can be sent to a specific API, the API that is hosting the LLM. And when this bucket is empty, well, pretty much all requests are being queued up and just waiting till the time the bucket is filled up and the API can handle more requests. So adding a queue to the request is something that can be done. What else? As I said, the exponential time off of the request is also something that can be implemented. I think this is going. It's so easy to implement, but I think it's going to bring, well, huge improvement into the user experience and the application performance as well. So this is something that can be done. Pretty much those are the things that comes on top of my mind. Of course, you can do load balancing, you can do split requests and so on, the request rerouting, all those stuff that we've already talked about. But I cannot think of something new to this point. Yeah.
And Alex with the ever-present elegant solution to the problem. But right now I'm going to, let's say, come here and say, well, this community is critical, and this system is absolutely critical for my website, and I make a lot of money off of it. I will buy my own hardware.
Yeah, of course, you can self-host this, of course. But even if you self-host this, even with the upscaling of the cloud infrastructure that you can currently have, model can handle X amount of concurrent requests at the same time. And some models have limitations. So what you're going to put several different instances of the same model?
Yeah, this is something that actually was discussed in one of the topics of trying to overcome rate limitations in the OpenAI forums. And some of the people who are part of the discussion came up with, at the end of the day, they came up with two possible ways. You have high criticality and high number of users that are using burst requests. How do I do this? Where is my order? I need help unlocking my account. Burst requests. And you would go on and pay for your own hardware that can manage this using small language models or using large language models, but quantized in a manner that is meaningful so that you have a small memory footprint and you can instantiate more hardware. Or the other option that was considered, multiple OpenAI accounts. Now, I'm not going to go into the details of stating whether this is okay in terms of the usage policy of OpenAI. I'm not prepared to say it's okay or it's not okay, but basically these were the two possible solutions.
I have seen this in action actually, just because the product was hitting so many limitations on so many levels, and not only for the tokens but also for the image generations and so on and so on. So the team that was handling this pretty much implemented their own rerouter, and it pretty much reroutes some of the requests to OpenAI, some of self-hosted, some of different AIs providers and so on. So they can handle pretty much the whole flow of requests. And of course, this brings another topic and issues about consistency, but this is totally different topic. We're not going to delve into it. You can cache things. I mean, this is probably the easiest option that's possible, and we're going to talk about caching and all those strategies in cost optimizations. But you can cache things, and I think there is this good thing about semantic caching, where you can cache, let's say, a prompt, and if somebody makes similar but not exactly the same prompt, it's going to immensely reduce the impact on the LLM. So this is something that's probably it's good to be noted as well.
By the way, Langsmith has a functionality which can actually assist you in managing such cases. If you're implementing OneSmith, it has, if I remember correctly, 5,000 free requests that you can record. I believe this was the correct term, record. And this is option A. Of course, there are options probably ranging from A to Z. But the other thing that comes to mind when you talk about caching, it is utilizing pre-built NoSQL databases. And I mean NoSQL databases in the sense that it's the cheapest possible storage solution. Microsoft has this option to monitor your model using application insights in Azure. So it is a viable solution that is built around precisely that idea, having a most common query, let's say, how do I unlock my user in some obscure system or whatever, and having the pre-cached answer, well, go to menu, unlock users, and press unlock.
Yeah. And it really doesn't matter the type of the question. How do I unlock my user? How can I make my user unlocked? How can I whatever? It pretty much has the semantic of the question of the inputs, and from there it provides answer. Funny thing that you've mentioned about storing things into cheap vector databases. Recently, you have talked well, pretty much told me, and we were talking about serverless vector database. What can you tell me a little bit more about it?
I believe that we're delving into the next topic actually.
Cost of well, it's hard to separate those, to be honest. Let's explain the model, what you're talking about, and then again we are going to talk about it afterwards when you're talking about cost optimizations.
There is a vector database that I'm a air quotes fan of. It's called Pinecone. And Pinecone is a distributed cloud-based vector database, which has recently made a new addition to the services that it provides. It is the option to have a serverless vector database, which is a great option considering the fact that Pinecone has high dimensionality. I believe last time I checked it was 1536 dimensions per vector database. And now adding the option to have it as a serverless with a hit-up time of milliseconds is something that would definitely improve any company and any product that is relying on retrieval-augmented generation utilizing vector databases. In the past, you would have to keep such a vector database always on. And definitely the costs of the compute resources, because you're paying for both storage and compute here, are not something to be missed. And if I give you another example, for example, Microsoft AI search, the vector database that Microsoft has, a single instance costs $250 per month.
They have, I think they have a cheaper tire. I've used it. No,
No.
no.
If you're using AI search, you're a corporation, then you have to pay.
Okay.
And now that Pinecone is distributed and cloud-based, and you have the serverless solution, you can definitely rest assured that even with, let's say, a scheduled hit-up early in the morning, for example, when your clients, users, whatever, are starting their workday, you can have a scheduled hit-up.
Just to warm up.
Just warm up, just to get the database, up and running. You will be having a ton of money saved because let's say, the downtime, let's say after working hours, is something that you're not going to pay for.
Yeah, and not always you need it. So naturally, we're going to the topic of cost optimizations and cost management as well. What are the main strategies that can be implemented in order to make sure that we are cost efficient and what we are creating makes sense in the end? Because if our expenses are exceeding our incomes, pretty much it doesn't make sense to have it. So what can we do in order to make cost estimation and, of course, cost savings.
There are multiple approaches, and in the past few minutes, actually, we discussed several of them, but because those topics are so intertwined, maybe we can now accentuate on the specifics. We talked about optimization in terms of tokens. As you know, all of the proprietary models are based on per token cost
Pricing model, yes.
Yeah, so less tokens,
Less money.
less money, and no limits, as we said a
Yes.
few minutes ago. So this is a twofold approach. Make sure that you're not hitting the token limit, and make sure that you're not hitting your wallet.
Actually, there are two types of cost structure when we're talking about, pretty much hosting models. The one is, as you mentioned, per token or per 100 token. Actually, it's per 1,000 of tokens. The other one is pretty much if you're self-hosting the model yourself, probably you're going to pay a little bit more about the infrastructure, about the servers that are going to run. Probably you're going to need to pay some money to the model creator. There are some things in this area as well. So those are the two main topics. You're either paying per token or you're paying for hosting. Those are the things. What can be done? We have already talked about the tokens. What can be done in order to achieve less expenses into the other direction about the hosting part?
We are talking about generative AI, and by generative AI, people usually think about large language models. So everyone's heard of Llama, or at least everyone who is in the field of IT recently and interested in AI has heard of Llama. Everyone has heard of Falcon, of those models that are derived from them. But there is a very interesting model that recently has been released for free. It's an open source model by Microsoft. It's called Phi-3. And Phi-3 is a small language model. If you're going into the direction of having a task which can be serviced by a model which is not so sophisticated, then you can definitely go into the area of small language model, because this is not the only small language model that is out there. So again, picking the right tools for the right job. A small language model can be hosted even on hardware that is not GPU bound. So imagine you have your own server farm inside of your office, and it's most likely not going to include NVIDIA A100s, but it's going to have several, well, not thousand, but several very powerful CPUs and terabytes of memory. So you can self-host a small language model that can definitely service an office in cases where you don't need the excessive knowledge that LLMs actually come with.
Okay, so to summarize, you have options. And the good thing about having options is that when we need to employ the help of LLMs or Gen AI for the things that we want to use it for, probably the first thing we need to do is to make sure that we're using the right model for the right job. This is going to save us a lot of money and costs, of course, just because employing the most famous, most recent, the biggest ones is not always the good options.
Definitely. Going for the hot topic, following the hype is not going to be the best thing that is going to happen to your wallet when it comes to applying generative AI solutions. While we are discussing this, there is another item that we actually should definitely mention. This is not relying on RAG, not relying on retrieval augmented generation, but so long as you have the time and the manpower, because basically it will require manpower, you can do some fine-tuning on a model and apply all the other optimization techniques that you can have with a fine-tuned model. You can quantize it, reduce the weights. You can make sure that it is hosted on a hardware that is providing the proper balance between inference speed and availability. And hopefully this is going to be enough so that you drive your costs into the, drive your costs down when it comes to self-hosting.
Most definitely. This is one of the best way to make sure that the model that you're using is optimized. There are some downsides of this and those. For example, how do you scale this? How do you make sure that it can handle the loads when we're talking about high demands and so on? What will happen if, because this model is becoming pretty much a single point of failure. How can you scale this up? How can you scale this horizontally and vertically, of course, in order to make sure that your service is not being interrupted by unexpected something? And this something can be a lot of requests, hardware malfunction, hardware limitations, and so on and so on. So this is most definitely one of the great options you can do, but have in mind that it brings some downsides as well.
Considering the fact that we are on the topic of self-hosting, there is one good thing about self-hosting. Well, you are your own master.
Yeah, that's true. That's true. Also, another interesting, well, actually, we have already mentioned this on several occasions during our conversation today, but it's extremely useful cost optimization strategy, and it's really a simple one. It's called batching. That's something that everybody are handling and pretty much doing, but this also can reduce costs a lot just because LLMs are handling batches way much easier and way much efficient than separate requests and separate prompts.
Actually, when it comes to mind, if I remember correctly, the API documentation that OpenAI has, when it comes to batches, I believe that they are stating that batching can reduce the costs by up to 50%, which is rather impressive, in my opinion. Just batching, driving your costs down by a 50% rate, it's really impressive.
Yeah, most definitely. And if the whole process of batching is something that's suitable for a specific business case that people have, and you can implement batching, most definitely it's going first to optimize the performance of the application, and second, it's going to reduce the cost, which is, well, pretty much win-win from all sides.
And there is another technique that OpenAI has, and I believe not just OpenAI has, I believe Gemini and the Opus by Anthropic has, is the option to have a stop token.
This is also something that can help reduce costs, because if you use stop tokens and pretty much control the length, again, this is going under the topic of token optimization, but this is something again that can be used especially for chatbots and all those stuff, where you don't want the chatbot to pretty much write novels in the responses. You can limit the responses in with stop tokens, and pretty much you can reduce the cost, of course. Good call.
But considering the fact that if you're going to the business of a generative AI solution, you will likely be forced to come to a head with certain costs that you cannot overcome. This is sooner or later going to happen. Uh, Picking of the right technique for cost optimization is not going to be a single time effort. As models evolve, we are going to be faced with the ever changing prices. And right now, why am I saying this? Because when GPT-4 preview 11.06 was available as a general availability in the beginning, its cost was the same as GPT 3.5. They're trying to promote the utilization of the new model. And right now, GPT-4 Omni is available, and its cost was half of that.
Well, things are going to get more affordable. I think with the development of Gen AI and hostings, GPUs, and all those stuff, if you can imagine 20 years ago, 30 years ago, processors and all those microprocessors that were created. And if you have seen a hard disk during this time, it's enormous thing, like a huge room, and it's going to be a hard disk that is going to be, I don't know, several kilobytes or at least maximum. And now they are in the palm of our hands. We have terabytes and even more in just small devices. So things are going to get better, most definitely. Things are going to be more cost efficient. Probably there are going to be some new stuff that are going to cost money. We're going to talk those about in the future, of course. But let's talk about now. What can we do now? What are the options? Actually, a fun thing, I've seen interesting diagram that was stating that in the beginning, if you want to start something, it's more profitable, well, not profitable, but rather cost efficient, to be on a token-based subscription or token-based price model. But in the long run, self-hosted is killing it in terms of cost efficiency. So really depends on what you need, what time you have. But if it's for something like proof of concepts and all those stuff, I think nothing can beat the token monetizing strategy.
Oh, I completely agree. Actually, this is a nice callback to the
The thing that we were talking
Yeah.
about when we were comparing, this is the tech duel that we had, I don't know, a couple of weeks ago. Yeah, we were talking about this, so go check it out. What else can we suggest as a good cost optimization option? We've already talked about several of those. We have talked about reducing the tokens that are being used. We have already talked about cache and caching the responses and the requests and pretty much the whole interaction. We have talked about outsourcing some of the decision making and things to RAG, so they can do the heavy lifting, and then the LLM can pretty much wrap everything into a nice shiny response.
Well, there is one thing that is that came up 6 days ago, the WDC, Apple's developer conference. I don't know whether you followed this one.
I don't follow Apple.
You will. So, so at the WDC, Apple announced that they're going to implement not AI. They're not going to implement artificial intelligence. They're going to implement Apple intelligence. I will make a pause here to let that sink in because it sounds too pompous for me. I mean, Apple intelligence. But Apple is making a deal with OpenAI. What type of deal? Well, I don't know. What they're
Well,
going to be,
they disclose several stuff on this topic, that they are going to be using services provided by OpenAI, and OpenAI is going to be using the data.
And this is the interesting part because I'm not going to go into the area of privacy and
Yeah, Apple are.
yeah, I'm not going to delve in that, but specifically on the topic of model size and optimization, Apple is going to have only the newest devices available being equipped with the Apple intelligence. And this is going to come as something very frustrating to users that are not owners of the latest Apple iPhone.
So you're saying that Apple is implementing something only for the new devices, and they're forcing their users to buy only the new devices? Oh no, I haven't seen this one coming.
No, it's well, it's more or less related, according to them, to the hardware of the devices. It's going to the interesting part here. Why I'm getting to this topic right now, is because they are outsourcing. I'm going to use this part of the calculations to the device itself. They're going to use services provided by OpenAI through Siri, the assistant that Apple currently has, and the explanations that they provided the conference and introduction of this new feature, is that this is going to be dependent of the application memory that you have on your device, not on the neural engine that has been a part of of Apple devices for the past, I believe, 2 or 3 models of iPhones. It's going to be dependent on the memory that you have on board. The Siri assistant that you have available on the MacBooks is going to have Apple Intelligence only if you have the M1, the Apple Silicon chips. But what I find very curious, and why am I discussing this on the topic of cost management, is that Apple are trying to strike a balance here between outsourcing calculations on the device and thus not getting additional fees to the customer, and at the same time having sort of a very restrictive policy towards users that are not owner of the latest and greatest, which is, again, I'm repeating myself, but it's very frustrating.
Okay, so we talked about Apple. We laughed about Apple. At least I did. We talked about some interesting topics. We talked about outages, service availability. We talked about token limits, rate limits, of course, cost management, cost optimizations, strategies. We've covered a lot of ground. I think this was really interesting conversation. Thank you, Martin, for being here, sharing your knowledge and expertise. We're going to make another one. Most definitely, there are a lot of new stuff that we can talk about. But thank you for being here. Thank you for participating. Thank you to pretty much everybody that listened. And stay tuned.
Thank you, Alex. It is always a pleasure to be part of these podcasts. I hope that the listeners today had some really interesting key takeaways that can help them in their quest for achieving AGI and superiority of the artificial intelligence. And as always, thank you to you and to Oxidio for hosting this event.